and then we'll continue on with even and odd functions tomorrow. Okay, so the first thing we're going to talk about is the end behavior of a function. Define what end behavior is, and then learn how to write it down in proper notation. End behavior. So yesterday we described the notation for positive and negative infinity. So remember that as we increase in the x and the y direction, we're going towards positive infinity. And the infinity symbol is like a sideways looking 8. And then as we go in the negative direction, we're heading towards negative infinity. And what we're looking at with a function is we're trying to figure out where the function is heading towards. So as I go out towards positive infinity for the x, I want to figure out if is my function heading upwards or downwards. Okay? And on this other side, as I go in towards negative infinity with the x, I want to figure out where the function is getting towards, either it's heading up or it's heading down. I only have two options, pretty much. Okay? So the end behavior describes the function as x approaches very large positive numbers. Okay, so instead of saying as x approaches very large positive numbers, mathematics is all about creating symbols and symbolizing English words into symbols. So what I'm going to write this as x, and then I'm going to use approaches for the arrow, and very large positive numbers we know would be positive. Okay? So this means the exact same thing. And also as x approaches very large negative numbers. So that is as x approaches very large negative numbers, or x approaches negative infinity. So we'll just do a quick example. Hopefully describing the end behavior given a graph is going to be pretty straightforward. Okay? Describe the end behavior. But ultimately what we want to be able to do is to describe the end behavior of functions when you're not given a graph, you're only given the equation. So here's my function, y is equal to f of x. So when I'm asking for the end behavior of a function, what I'm asking for is as x approaches very large positive numbers. So as x approaches positive infinity, right? Where's my function heading towards? So remember that I can either call my function y or f of x. They're interchangeable. So where is y heading? And then once I do the right side, then I look over the other side, because there's always going to be two sides, the positive side and the negative side. As x approaches negative infinity, where is y approaching? So as x approaches positive infinity, okay, so as I'm going along, right, I can take different values for x, any value I want, and then the corresponding function value for y would be where the curve is. So if x was this value, y would be that. If x was this value, y would be that. If x was this value, y would be that. Does that make sense what I'm talking about? Okay, so as I go along bigger and bigger value of x's, where is the blue function heading towards? What does it look like? Second? Yeah, negative infinity, right? Because as I go further and further along here, I have to go way down here in order to touch my curve. I keep doing that. This arrow indicates that it goes on forever. And if ever you get a graph like this, and you do get it in the textbook, it's not going to change. It's not going to change again. You know what I mean? But it's not going to do another little swirly thing. It's just going to keep going down forever. Okay? So the way I indicate that is y is heading towards negative infinity. On the other side, as x approaches negative infinity, where is my function heading towards? Positive infinity. Okay, so as I go along, get larger and larger values of x, I'd have to go higher and higher in order to touch my curve. So I keep going higher and higher. I'm heading ultimately towards positive infinity. Does that make sense? Okay, so that is the essence of what end behavior is. Let's try to figure out end behavior without giving a graph. So ultimately, we're trying to answer the question, as x heads towards positive infinity, where is y heading? And as x heads towards negative infinity, where is y heading? So remember, these are polynomial functions, and polynomial functions are continuous over the entire real number system. All that means is you can go from one side to the other side without ever having to lift your finger if you're tracing the function. Okay, so it's going to go on forever. Okay, here it's pretty easy to see. Here, maybe not so much. So when you are determining the end behavior of a polynomial function, what I want you to look at is the leading coefficient and its term. So pretty much you want to look at that term. That's the only thing that's going to affect its end behavior. Anything other than the leading term isn't going to affect the end behavior. This guy does. Okay? So now you're just going to do some mental mathematics. As x approaches positive infinity, okay, so I'm going to do that. X approaching positive infinity, I'm going to take a really big number. A really big number is like 1,000. If I take the number 1,000 and put it to the power of 4, I'm just going to get a really big number. That's still positive, right? And when I multiply it by negative 8, it's just going to become a really big negative number. And if I take a million, put it to the power of 4, what's my answer going to be, positive or negative? Correct? It's still going to be negative. If I take a trillion, put it in, it's still going to be negative. So where do you think this guy's heading towards as x gets bigger and bigger? Yep. Yeah, negative infinity. Now think about what value, what value y is heading towards as x heads towards negative infinity. Why? Exactly. Okay, so no matter what negative number you put in here, right, as soon as you put it to the power of 4, it's going to become a positive answer. You take that, multiply, it's going to become negative. So every time you take a bigger number, you're just going to get a bigger and bigger negative number. Make sense? Okay. So this is heading towards negative. Okay, so I'd like you to try this one, and then we'll take it up together. Take a minute and try to do that one on your own. Okay, so as x heads out towards positive infinity, what is the end behavior of this polynomial function? Keith? And as it goes towards negative infinity, it is... Okay. Anybody agree, disagree? Agree with the first one. Yep. It is. Okay. So I'm just going to go over why that is. Okay. So first of all, what term am I using to determine the end behavior here? That? Yeah. Exactly. Okay. So this isn't in standard form. So make sure you're using the one with the highest exponent, the one that gives you the degree of the polynomial. So if I take a really big positive number, put it to the power of 3, it's still going to be a positive number. Then multiply it by positive 7, it's still going to be a positive number. So it's heading towards positive infinity. Now, if I do it with a negative number to the power of 3 is going to be a really big negative number. When I multiply it by positive 7, it's still going to be a negative number. Ultimately, all the numbers are going to get bigger and bigger negatives. Does that make sense? Yeah. Oh, okay. Yeah. So purposely, that's why I wrote it like that, so you remember to identify. It might even be a good habit to take all polynomial functions and write them in standard form, okay, so you don't make that little mistake. Any questions on identifying the end behavior from a graph or from a function? Okay. Now, even though I did 2 examples here, what's the degree of this polynomial? Yep. What's the degree of this one? Okay, I'm going to make some conclusions about even degree polynomials and odd degree polynomials. And in your guide, they do that as well. Okay, but if you notice in this is an even degree polynomial. The end behaviors are the same, and that will always happen. Okay, so for even degree polynomials, they have the same end behavior. And by even degree polynomials, I just mean that the degree is an even number, right? So even degree polynomials have the same end behavior. So if one side's going to positive infinity, ultimately the other side's going to happen, and vice versa. Odd degree polynomials, you'll see that they have opposite end behavior. So if one side goes to the negative, the other side always has to go to a positive. Any questions on that? Pretty straightforward stuff. Okay, so let's get on to finite differences and using finite differences in order to identify the degree of a polynomial. Finite. So example, determine the degree of the following. Okay, so what's the degree of that polynomial? 1. Okay, because the exponent on the x is 1. And hopefully we all are able to identify the degree of any polynomial, right? So polynomial functions, right, all the exponents have to be positive whole numbers. Just look for the highest positive whole number, okay? So polynomial functions can be given to you as a equation, or an expression, sorry, or it can be given to you as a graph, or it can be given to you as a table of values. Okay, so here's a polynomial function, right? And I want to determine the degree of this polynomial function. Back in grade 9, you would have gotten a question like this and would have said, is this function linear? Does anybody recall how you would have figured out if it was linear or not? Using the table front? Exactly, first difference. So what you were really doing is something called a finite difference table. Okay? If the first differences match, then it was a linear function. If it didn't match, it didn't. Okay? And that's essentially what we're going to do now. Is we are going to find the finite difference table. So we're going to find the first differences. If they match, we know it's linear. If they don't match, then I'm going to find the second difference. If they match, what do you think it's going to be? Okay. Which one? For 2.
Oh, for 2.
Quadratic. It's going to be quadratic. If it's 2, and then if it's 3, it'll be cubic. Okay, so pretty much we're just going to keep going and finding the first, second, third, maybe even fourth difference until we get them all to match. Okay. How do we find the first differences again? In which column? Good. So you subtract this from that. Does it matter if I would have done this minus that? Correct? Yes, it does matter. Okay. So make sure you take this and subtract that. So I'll show it for the first one. We're taking 70 and subtracting off 173. So if you get a question like this on the test, which you probably will, you don't have to show me that you're doing that. You can just go 70, subtract 73, put the answer there. Okay? You don't have to show me all your steps. So if you do that, this is negative 103, that minus that. This minus that is negative 51. This minus that is negative 17. This minus that is negative 1. And this minus that is negative 3. Okay. So the first differences don't match. Move on to the second differences. You find the second differences in the exact same way. You take the number below and subtract the number above. So if I do that, in this case I get 52, 34, 16, and negative 2. They don't match. Now I'll try the third difference, and if I do that, you notice that the third differences match. Because the third difference match, that tells me that the degree of this polynomial is 3, and a degree 3 polynomial has a special name. It's called a cube. So pretty much that's all you're going to need to know for finite differences for your test. Okay. In your guide, they'll ask you to come up with the equation. That's using the graphing calculator. So remember I said that there's not going to be any questions in your test involving the graphing calculator. Any questions on finite differences? So they're used to determine the degree of the polynomial, just figure out the finite differences. And to be honest with you, if you're writing your test and you've gotten to like the 5th or 6th differences and they don't match, you've done something wrong. They're going to match in the first 2, 3, or 4. Okay? Okay. Transformations. Your guide does a whole bunch of pages on transformations, which is just really a review from grade 11 and grade 10. So I'm going to go over what you need to know for the transformations part. Okay? So transformations is you're taking a function, which we call the parent function, okay, the original function, and you're putting it through a transformation. So we're going to put numbers in front and numbers inside of the function. What your job is to know what each one of those letters do to the function. Okay? So anything outside of the function, so I mean outside of the function is the a and the b, that affects the range of the function. So the a and the b values affects the range. Okay? So that means things are going to happen in the y direction, up or down. So this plus b will move things up or it'll move it down. This a will either stretch things or compress things or flip things all in the y direction. The c and the d values, they're inside of the function and they affect the domain. So this D value will either move things left or right. The C value will either compress things, stretch things, or reflect things, all going in the X direction. Make sense? Okay. So you will be responsible for something like this. So I'm not going to go over every single thing, right, because it's in your guide, and you can go and review this, what each one of them does. So state the transformation. On the graph of y is equal to x cubed. So that's the parent function. That's the one we're transforming. If negative 2 Okay, so say the transformation on the graph y is equal to x cubed if y is equal to negative 2 bracket x plus 1 quantity cubed minus 4 is applied. So basically what you need to tell me is what does the negative 2, this plus 1, and the negative 4 do to the original graph of this function? Okay, so we'll just do them in order. Whenever there is a negative, I like to split it up in two. What does the negative do to the original function? Well, right. Okay, so you have to say what it's doing and what direction it's doing. Okay, so reflection in the x-axis. Right, because anything outside of the function does it up and down. Right, so the up and down, you're reflecting it, you'll be using the x-axis as your mirror. What does the 2 do to the function? Here? Which way? Right, so that's vertical. Okay, by what? Right, exactly. You have to say that. You have to say which direction, what it's doing, and by what factor. Okay, so you would say vertical stretch by a factor of 2. Okay, this plus 1. What does the plus 1 do? Now we're working inside of the function, so we're thinking about the domain, right? Exactly. So remember, anything inside of the function, it does the opposite of what you think it would do. Okay, because this is the plus, you think it'd move it to the right, but it actually moves it to the left. Okay, if there was a C value, there's not one here. When I say there's not one, what's the actual C value? 1. Okay, that would do the opposite. Because if this was a 2 here, it doesn't stretch it, it compresses it. If there was a fraction, it would stretch it, not compress it. Okay, so you can say, and you don't have to say a vertical translation of negative 1 to units to the left. You can simply say moves 1 to the left. That would be good for me as well. As long as you articulate moves 1 unit to, as long as you articulate what's happening. You can even say to me horizontal translation of negative 1. Okay, that's good enough. And then finally the negative 4. Bronson? Exactly. Moves down 4 units. So really, there's a big section in the guide about transformations. Really, the most important thing that you're going to be responsible for in your test is identifying what each one of these parameters do to the function. Okay, so you'll get a question much like this with obviously different numbers, and you'll just have to tell me what each one of those numbers is doing to the function. Okay? You don't have to graph any transformations. Okay, you just have to identify them. Okay, are we good? Okay, so tomorrow we're going to go over even and odd functions, which is different than even and odd degree functions, a whole different thing. Okay, so I'm going to go over that tomorrow, and then remember that Thursday, if you're ready to write your test, then you can write it Thursday. If not, we'll make arrangements for you to write it on Friday.